one of the biggest mysteries out there, consciousness itself. We're going to unpack a really fascinating new theory that suggests our conscious reality, well, it isn't some perfect photograph of the world. Instead, it's something way more practical, a good enough model that's built for survival. So, how does that work? Let's get into it. So, think about this for a second. We all know the feeling of hot, right? You touch a warm mug of coffee, and that sensation just seems direct, simple. But what is that feeling, really? It turns out, what's happening underneath the surface is anything but simple. And this is where you see the incredible gap between physical reality and what we actually experience. The reality of heat is just this storm of microscopic chaos. You've got energy transfers, molecules vibrating all over the place, nerve cells firing like crazy. But our conscious experience of all that, it's just one single unified concept. It's hot. Our brain takes that almost infinite complexity and boils it all down to one useful piece of information. And this massive simplification is right at the heart of a new framework called the CRPBCE theory. Yeah, it's a bit of a mouthful, I know. But the core idea is actually super simple. Our brains aren't trying to create some perfect high-def copy of the world. Nope. Instead, they are masters of simplification, creating a good enough model that lets us act and act quickly. This whole process has a formal name, accepted representational reduction. Let's break that down, because it's important. Reduction is that massive compression of information we were just talking about. But the most important word here is accepted. See, consciousness isn't just about crunching data. It's about the moment the brain basically decides, yep, this simplified model, it's good enough for now. Let's run with it. The author of the paper, Georgios Fratoulas, puts it perfectly here. Consciousness isn't about capturing everything in all its glorious detail. It's about creating a simplified internal object, like that feeling of hot, and then accepting that object as your working reality.
So this brings us to the most important part of the whole theory, this act of acceptance. What does that really mean? Well, according to this paper, it's not some passive thing. It's the decisive moment where consciousness actually flickers into existence.
The theory argues that this acceptance step is the line in the sand. It is what separates a machine that's just computing from a mind that is consciously experiencing. It's the secret ingredient. To make this crystal clear, the paper uses this fantastic analogy, a simple thermostat. A thermostat takes in all this temperature data and reduces it down to a binary state, right? On or off. It computes and it acts. But, and this is the key, there's nothing that it's like to be a thermostat. It doesn't feel cold. A conscious system, on the other hand, does something extra. It reduces the data, yeah, but then it packages that data into a coherent internal object, the heat. And then, critically, it accepts that object as its working reality. It commits to this simplified model for everything. For memory, for predicting the future, for deciding what to do next. That commitment, that final step of acceptance, that's the game changer. So how does this whole process of reducing and accepting actually work from moment to moment? Well, the theory lays out a pretty clear step-by-step cycle. Let's walk through it. Okay, so first, it all starts out there, in the world. Some phenomenon happens, a sound, a sight, a touch, and it just bombards our senses with a ridiculous amount of raw data and physical complexity. Next, the brain gets to work. It acts like the world's most aggressive spam filter. It performs this massive reduction, throwing out almost everything and keeping only the tiny little fraction of information that it thinks is relevant for whatever you're doing right now. In the third step, all that simplified, relevant data doesn't just float around. It gets packaged up, or bound, into a stable, coherent concept. This is how your brain takes the color red, the shape sphere, and the texture smooth, and bundles them all together into the single internal object of a red ball. And here we are, the final and most decisive step. The system accepts this internal object. It decides, okay, this simplified model is good enough. And that model becomes the official version of reality that gets plugged into your memory, your predictions about the future, and your plans for what to do next. Okay, so this is where the theory goes from being just fascinating neuroscience to something that could be, well, world-changing. The paper doesn't just describe how consciousness might work in us. It suggests we could use these exact same principles to build it in a machine. I mean, that is a bold claim. The author literally calls the CRPBCE framework a constructive blueprint for building what they call perceived consciousness in an AI. It's not just a theory, it's a recipe. So what's in this recipe? Well, an AI would need a unified model of its world, so it can integrate all kinds of information. And then, crucially, it would need something the paper calls balanced acceptance thresholds. Balanced just means having a positive or negative value. So the very act of accepting a model would need to feel good or bad to the AI. Kind of like a digital satisfaction when a model works, or frustration when it doesn't. And finally, of course, that accepted model has to be fully plugged into the AI's memory and decision-making systems.
And that, of course, leaves us with the ultimate question. If we build an AI that follows this blueprint to the letter, one that reduces data, binds it into an object, and then accepts it as its reality to act on, is it actually experiencing something? Is anyone home? Or is it just an incredibly sophisticated machine running a very, very clever program? This theory gives us a powerful new way to think about it, but the final answer, well, that's still anyone's guess.